So we've been talking about pins and how they can be inputs and outputs and be digital and analog. And so now we're going to talk about how you do that from the code. So what code do you need to write? What function calls do you need to make in order to use the pins as inputs and outputs, and in order to use them as digital and analog? So this is from the sketch point of view, what you have to put in your sketch. Basically, we're going to go through the library function calls, the library functions, the Arduino library functions that you have to use in order to use the pins. So pins can be inputs or outputs. Not all the pins. Some of the pins can't be inputs or can't be outputs. Like, for instance, the analog pins, right? Analog pins, they can be inputs, but they can't be outputs. But let's say the digital pins, the standard digital pins, they can be input and output. So you have to, before you use the pins, you have to select if the pin is going to act as an input or an output. And you should do this for all the pins, or any pin that you're going to use. You got to select it up front. So before you use it, before you try to read from it or write to it, you have to assign it to be an input or an output. Now, if you don't do this, something will happen. It'll have a default value. So by default, the pin will either be an input or an output. And to tell you the truth, I can't remember which, but you can look that up. But it will be default to something. But you should never rely on the default value. You should always use this before you access the pins. You should call this function, this pin mode function, in order to assign the pin to either an input or an output. So the function is called pin mode. And note that the capitalization matters. So lowercase pin, and that M has to be capital. So you call this function pin mode. It's a library function. It takes two arguments, pin and mode. The job of this is to set a pin to be either an input or an output. The pin, the first argument, is the number of the pin, or the reference of the pin, the reference name of the pin. Now the digital pins, their reference names are just their numbers. So pins 0 through 13 are the digital pins. The analog pins, you have to call them A0 through A5. Those are their names. So the pin has to be 0 through 13 or A0 through A5, and that's the only valid pin numbers for an Arduino Uno anyway. And if you go to a bigger Arduino with more pins, maybe you get more numbers, but for an Arduino Uno, those are the valid pins. Then the mode, which is the second argument, there are three possible modes. The first mode is input, and that means you want this pin to be an input pin. The second mode is output, which means you want it to be an output pin. You're going to drive values onto it. The third mode is input pull-up. So input pull-up, basically what that does is it makes the pin act like an input, but it reverses the polarity. So when they drive 0 volts on it, when they drive it low, you read it as a high. Or when they drive a high, you read it as a low. So it's a reverse polarity input. So digital inputs. So let's say we're talking about the digital pins. And we've assigned this pin to be an input. We use pin mode. We made pin 0 an input. Now we want to, in our code, actually read from the pin, read a value from the pin. So for that, use this function called digital read. Returns an int, and it takes as an argument, one argument, the pin. And it just returns the state of the pin, which is either low or high. Now note that it returns an int. So if you look at the example, I create an int pin val. I say pin val equals digital read 3. So what that does is it reads the state of pin 3, assumes it's either 0 volts or 5 volts, and returns low if it's 0 volts, high if it's 5 volts. Now notice that pin val is an int, so you can interpret that as a 0 and a 1. 0 meaning low, 1 meaning high. So that's what this function is for. Now, one thing to note is that the pin mode function that we talked about before, usually you invoke that in the setup, right, where this might be invoked in the loop. You invoke it in the setup because typically with these pins, when you set the value, when you set the input or output state of the pin, you usually do it once at the beginning. That's common. Now you can change the pin mode while it's running, but usually you see inside the setup is where you set the pin mode, where the digital reads and digital writes, you usually see those inside the loop. So this is how you read the value of a pin. And then if you want to write to a pin, you call digital write. That takes two arguments, the pin and the value that you want to write to it. And the value has to either be low or high, which would be 0 or 1. 0 volts, 5 volts. So it assigns the state of the pin. So if you say digital write, like I do here, digital write 3, high, it's going to set pin 3 to high, which would be 5 volts. Now, for the analog pins, remember the analog, we can't drive analog output data, right? We can't take a pin and make it an analog output, but we can read analog input data off of the pins, off of the analog pins at any rate. Now, what actually happens is that the analog value, remember that our processor, it is a digital processor, okay? So it really needs to see digital values, but we want to be able to read analog values, so that processor inside it, the microcontroller inside it, has an analog to digital converter, which when you call this function analog read, it reads the analog value off of the pin and then converts it to digital using the analog to digital converter, and then our code gets the result. So what happens is analog read returns the state of the input pin, of the analog input pin, but it returns an integer from 0 to 1023. Now 0 is the bottom of the range, so if you got 0 volts on this pin, it's going to return you a 0. And the top of the range is 5 volts, right? So if it sees 5 volts, then it's going to return you a 1023. And it'll return you numbers in between according to the voltage. So for instance, say your voltage is right between 0 and 5 volts, so you get 2.5 volts, right? Then the number that this returns is going to be right between 0 and 1023, which is 512, right? Something like that, 511, 512. So it's going to return you a digital number that corresponds to the analog voltage that it reads off of the pin. Again, it returns an integer. So you can see in the example, pin val again is an int. I say analog read A3. Remember that the pin that you pass as an argument to this has to be an analog pin, because it's analog read. It won't work for a digital pin. Thank you.